Hi guys, today I'm very excited to be doing this tutorial because this is the very first tutorial where we use 3D features of FXGL. And it's going to be a very simple game where we have some things spawning in the air. They're going to fall to the ground. If they touch the ground, you lose points. There's going to be a platform between the ground and the object, and the player is able to control that platform. If you catch the falling objects, then you're going to get points. So here's my app that extends game application as per usual. No changes there. The POM.xml contains, well, it has dependency on developer version of FXGL. By the time this video is released, it's going to be 11.15. So if you'd like to use that for this tutorial, that should be fine. It's going to contain all the 3D stuff. And let's proceed. So we're going to set, generally speaking, there is very little difference between 2D and 3D in FXGL. I quite like this API that supports both seamlessly. So for the most part, like 90% of our code is going to be exactly the same, whether you're writing a 2D game or 3D game. One important thing to enable is set experimental 3D to true. You can see that it's still experimental. It'll be a few versions before it will be finalized. But the API is more or less finalized, so you can start using it. You just need to enable the 3D experimental stuff. Set width, let's go for 720p. Okay, so the very first thing to do is to create entity types as per usual. Create an enum, entity type. There are three things, as I just said. There's going to be a crystal, which is the stuff that falls down, just spawn in the air and just keeps falling. So crystal, ground, and platform, user controllable platform. And then let's create a factory. Crystal game factory. Implements entity factory. Again, it's exactly the same as in 2D. I don't think I need anything else. I'm just going to close the side panel. So the method signature is, again, the same that you would use in a normal 2D game. It's public, it's entity, it's whatever it is here, and spawn data. So the method signature is important. The name, not so much. I'm going to statically import FXGL stuff. We're going to pass data in so we can initialize X, Y, and Z and other stuff automatically. It's going to be of type crystal, and we're going to build it. Now we're going to add a bounding box because there's going to be some collision. So let's add a bounding box. This is where the first API I'm going to introduce, which is box 3D. This is a new shape. It allows you to create a cuboid around your 3D objects to create a bounding cube, essentially. Width, height, and depth, I don't yet know. Let's create our view. So I'm going to use a cone for crystal. Cone comes from this package, Scene3D, which is going to store various built-in 3D shapes that you're going to be able to use in FXGL games. Set bottom radius. There are a couple things we can set. So bottom radius is 1. Top radius is, well, for cone it's basically 0 because it's like this. But if we make it a truncated cone, how about that? 0.2. And then we're going to set height. The height is going to be 1. Let's go with that. Add view as per usual. Again, no changes there. Box 3D. So we need to essentially wrap this thing, right? So bottom radius is 1, which means the diameter is 2. So width is 2. Height is 1, because we said that. And depth is also 2, because the foundation of your cone is basically a circle. That looks fine. We need to set the collidable flag, so we're saying this thing can collide with other things. Let's actually use this and see how it works. So we need to add our entity factory. And then spawn crystal. Okay, so this is going to be our crystal, which is fine. We're going to need to spawn a lot more of these. So how about run? We're going to run a bit of code using 1 second as duration, rather as interval. So every second there will be a new crystal, maybe every 2 seconds actually. We also want to move this thing somehow, right? For that we need, as per usual, the components. We're going to use projectile component. Now, interestingly, this is 2D projectile component, but because we're only moving in one axis, which is down, that should be sufficient. We also have projectile 3D component, which we're not going to use in this case. So we're just going down, that's it. Speed is, now this is not in pixels, this is in kind of 3D measurement units. So let's try 1.5 and then we'll see. We also don't want any rotation. Rotation is useful for 2D movement. Like when you rotate your projectile to face the axis or to face the direction it's traveling. But in 3D, we don't want to rotate, not just yet. Nice. So every 2 seconds we get a so-called crystal spawned and just falls onto the ground. But there is no ground. Let's make a ground object. It's going to be very similar actually. Crystal, no, that's ground. We need to create a view first. We're going to use a box. This is a vanilla shape that comes directly from JavaFX from this package. Ground needs to be big, right? So width is 20, height 0.4 and 20. View, collidable, box 3D. Bounding shape needs to match because, you know, it's a cuboid, it's a box. So its bounding cuboid is exactly the same in terms of dimensions. We don't need this because well, the ground basically, the ground object doesn't move, doesn't do anything. That's fine, yeah. Let's spawn our ground. Let's spawn somewhere below, like 0, 5, 0. And then crystals are going to spawn up top, so 0, Y-axis -5 and then 0. And then let's add a collision handler. On collision begin. Now this is going to blow your mind. The collision stuff is exactly the same as 2D because there's, we don't really say anything about that in terms of, well, you'll see. We just say what type it is, say crystal, and then what type collides against, which is ground. And then you're given this nice callback, which is called back when there is a collision. So crystal, ground. In fact, let's do that. So crystal, ground. These are the actual entities that collided. What we're going to do is just remove crystal from world. And that is it. Provided they're all collidable, yes. They all have bounding boxes, yes. And they are given types, yes. So let's try that. This is our really big ground. We probably want to change the color. And then on collision, this is a really primitive collision. It only works for bounding cuboids that are axis aligned. It's still experimental, so there will be quite a lot of development work into collision detection, physics, and so on. But for starters, this is not bad. Okay, so that works. How about we change the color of the ground? Set material. This is Java FX API, so nothing particularly new here. New font material. Color brown, maybe. That should change the color of the ground entity. Yep, that's fine. Now we want to introduce a platform, which is basically like ground. Color blue, maybe. And much smaller. 1, 0, 2, 1. So the bounding box is going to match, and the type is platform. Let's spawn our platform. Let's spawn it at maybe something like that. And we also need to be able to control the platform. So I'm going to have a reference here to the platform. And then we need initialize input on key down, just on key, key code W. So how many keys do we want? I don't want to be able to move along the y-axis. It's a simple tutorial after all. So we'll just keep it X and Z. Platform translate. So W is going to move forward. So translate Z plus. I always keep forgetting because I keep switching between engines. And in some engines, Z positive is that way. In others, it's that way. In Unreal Engine, Z is upwards because. So we'll see how this works. Translate Z 1 unit. S, A, and then D. S is just going to do the opposite. And then this is X, this is X. So we move along the X and Z axes. Yeah, let's do that. It's important to run to test your code. Okay, this is super fast. So W and S works as expected. A and D work the opposite. Why is that? Oh, yeah, because of this. D is to the right, A is to the left. Yeah, that's fine. So 1 is actually too fast, so I need to define something like speed, and then maybe 0.25. And my platform is small. Okay, I'm going to close this, platform, maybe make it 2. Okay, so I've got a platform, I've got the ground, and physics. We need physics between crystal and platform. Crystal gets removed. We need to add a scoring system at some point. Given that most of the logic is done, let's add that. Let's add a scoring system. Init game variables. We're going to add score, which is by default 0. We're going to crystal ground increment score by -1, because the crystal just hit the ground. That's bad. If the crystal hits the platform, it's good. And then we need to show it somewhere. Let's add a UI. Score text, get UI factory service, new text, color. Actually, let's just try that. I don't know what that color is. Score text, text property, bind, get integer property, score as string. This is nothing new, so I'm not going to focus on that. Score text 50-50. Let's try that. Well, it should say 0, and given that I don't see it, I assume it's color white by default. So let's set it to color maybe dark gray, and then size something like this. I should probably set it to black because dark gray isn't that visible, but it's there. I can see it. So I collide with it, score goes up. Now if it collides with the ground, score goes down, right? Yeah, that is fine. Now this view isn't particularly useful, maybe. Change the camera position now. I think that would be a good finish to this tutorial, because we've done a little bit of 3D now. I don't want to go too far, because after all, this is the very first tutorial. Yeah, let's do the camera stuff and we are done. Okay, so the way you talk to the camera or you manipulate the camera is, first of all, you get a reference from the game scene. Get camera 3D. From the camera, you can either obtain the native JavaFX camera, which is perspective camera, or you can just use FXGL's wrapper API on top of it, which should be simpler. So get transform. We're going to, what I want to do is move the camera upwards, then to the right, and then kind of make it look at the ground so that you can see the entire scene graph from a different perspective. So I'm going to translate Y, which was going to move the camera upwards by 5 units. I'm going to move the camera to the right by 5 units, and then I'm going to make the camera look at the something, at the ground object. So I'm going to call this after I've initialized the ground. Look at ground, get position 3D. So each entity now has position, which is 2D by default, and then position 3D. It should be pretty straightforward from the name of the API, from the name of the method. So now the camera should go up, right, and then look at the ground. Yeah, that's what I expected, which is good. So we can see, we can collide, we can kind of move around. Maybe move the camera a little bit higher, and then do a spawn animation on these cones to demonstrate how animation is exactly the same as in 2D. And then we'll finish. So move the camera up even higher, so 10. And then when we spawn the crystal, shall we do it here? Yeah, so this is the entity, right? This is what it returns. And just before it is being spawned, we're going to call the animation builder and scale it up. So we're going to scale our entity from new 0.000 to 111. Build and play. So you can see that these values, these methods take both 0.2D and 0.3D. So the API is the same. Scale uniform 0. So I want to make sure that, first of all, it's scaled down to 0, so you can't actually see it. And then it's going to increase in size as it is being spawned. And maybe even play around with interpolators. Interpolators exponential ease out. Let's try that one. And hopefully we can actually see the point where they spawn. Nice. So it kind of does this effect. So you can see that the animation system that we've got in place in FXGL, which is quite powerful because of the various configurations you can apply, just seamlessly works with 3D stuff, which is great. You can even, and there's an API in the works, manipulate each individual vertex of your 3D model, but that's going to be coming in a later version. Right, on that note, we've looked at how to make a very simple 3D game with FXGL by creating a factory in which most of the stuff is familiar to you by now, but we did use a 3D bounding shape. We used a 3D model or 3D shape as a view for our entities. We used the material to change the color of the shape. We then manipulated the camera so that we can see the same scene from a different perspective. And there's also the FPS camera that will be coming soon. So you're actually able to make FPS games, first-person shooter type games. Everything else is generally the same, or exactly the same. All right. Let me know if you've got any interesting thoughts about how we can improve this. In fact, about several months ago, I hadn't even considered 3D support in FXGL. But after the JFX Days conference, we've got so much positive feedback towards the trajectory of 3D in FXGL that I thought that could be quite interesting. And now we have some 3D support in FXGL, which is great. So yeah, thanks for watching, and please leave feedback in the video comments. I'll see you later.